Hello again. So now that Helmut gave you a talk about stereophonic techniques for 3D audio in general, I will jump to VR in specific with the first part, which will be about 3D formats for VR microphones. And so I'm using the term VR as a collective term for all the new realities, the so-called ones. It's all about those glasses here. So those can be used for virtual reality experiences, which would be something like this here. This is an animated computer game in 3D. It is highly interactive, so you can see your own hands, you have controllers in your hands, and you can even move around, and the scene will change while you move around, so also the audio scene will change. So this is one thing, and the other thing would be 360-degree videos, where you could use those glasses for. It's a little bit different. It's not an animated thing. It's recorded with a spherical camera, a so-called 360-degree camera, and so there you can't really move. So you can just turn your head and the vision and the sound will adapt to that head rotation, but it won't be possible to really move around in the room. Not yet. Maybe future techniques will care about that, but so it's not that interactive as a normal VR game, but it's kind of similar in terms of audio things. And then there's also other formats like mixed reality, augmented reality, and others. And I won't go to each of one in specific, but what they all have in common is the audio target format, which is, in our case, binaural 3D audio with head tracking. So we have here a headphone format which are like, the left and the right channel, but those are actually something more, which is, you will record the whole soundscape, and the head tracking will take care of that. It will change the right way, like as you would be there actually. So this is a different format than you would have, for example, with a loudspeaker setup, which would also work in a VR application actually. It'll be much more difficult, I would say. So the first thing is it'll be in a room, and the room has some reverberation to it. So close proximity, as you could simulate with headphones, is not possible with loudspeakers. And also, not everyone happens to have a 22.2 loudspeaker setup in his or her room, and so binaural is the much more feasible way to go here. So that's our format that we are working here, that we're working with in VR. So yeah, how can this format be produced? So there's a thing called a Spatializer plugin, and I put some commercial ones on that slide here. These are the ones that I know. It's not maybe not all of the ones that are out there, but the most important ones I think are in here, like DVR, Oculus, Resonance Audio for Google. And these spatializers are plugins for a games development platform like Unity, or you could also use similar ones or some of these for video players for 360-degree videos, which then are also often referred to as binauralizers in that area. So, but it's actually the same. If you go again to the games development platform, those plugins look really a little bit unspectacular. So it's just a window in Unity, for example, where you have a global audio manager, and there you just simply select one global spatializer from a list of pre-installed ones, and then you can place objects in your virtual scene, and those objects will get spatialized to your headphones. This will be done by calculating the relation of that object to your momentary position of your head. And so you have the azimuth angle, which is like the horizontal angle, and you have the elevation angle, which goes up and down. And these are metadata of an object-based audio, which will consist of the sound file and the metadata. So the binauralizer takes all that and turns it into that binaural head track signal. This will be done by using the so-called head-related transfer functions, or HRTFs, and some other more proprietary methods of dealing with the original sound that you're working with. And this will all be done in real time, because when you're using this VR application or 360-degree video application, you have to adapt to that head rotation that you're doing while watching or while playing the VR game. So this is a real-time thing, and this is what the Spatializer plugin does. So what are those sound elements that we're working with here in VR or 360-degree videos? I split them up again into two groups now. So there's one on the one side virtual reality, and now also 360-degree videos on the other side. They differ a little bit here. That's why I put them into two columns. So what are the sound elements for the microphone techniques that we have to deal with in VR here? So on the virtual reality side, there are object sounds like dialogue and Foley sounds. So imagine a VR scene, and there's things happening, and some objects may do sounds, and these objects could be people speaking or other sounds that occur. And there's also some effects. An effect would be something like, for example, in this field, artificial head recording. Imagine like a swarm of bees would fly into your head, and this could be really be done well without head tracking, and thus with a artificial head or something like that. Or effects can also be something which was programmed by a computer. And then there's also ambience. It's the third thing here, which is really important for VR applications, because the ambience really gives you the immersion you need for this medium. I will speak more about immersion later, but ambience is something really important. For 360-degree videos on the right side here, we have actually the same, but there are two things coming to it on top. One of that is the 3D main microphone. The 3D main microphone is something that really fits into that 360-degree video, because you have a very special spot in your scene, which is the place where the camera is placed. And there the sound is of special interest for sure. So you can record direct sound as well as ambience at that one place, and it will kind of match the experience of the camera. And so here, and not for VR really, here you really get some benefit of having that microphones with it. And then to enhance this, you can also add spot microphones. So it's like a typical audio engineer technique then that you would, for example, use for classical recordings. So you have a main microphone and spot mics. It's the same here really. And so for 360-degree videos, this is a good thing to do. So now the upper ones, like object sounds, effects, are mainly mono things that you record. Especially the object sounds for sure. These can be recorded with normal microphones, mono microphones, which really fit the use case you have here. So it can be small diaphragm condensers, it can be lavalier microphones, it can be other small things that you might place somewhere and hide. But where do multi-channel microphone systems come into play here? So actually it's for the ambience and the 3D main microphone I was just talking about. Ambience, you could also say, I can model that with a lot of audio objects actually, but imagine like a vivid forest scene where there are rattling trees and animals maybe, or a stream surrounding you, and you would try to model all that with like separate audio objects. You would really raise that number of objects you would need here, because they're all on different spots and come from a different direction. So it might be just the better idea really to kind of put some of those objects together, and that is really where multi-channel microphone techniques comes into play handy, and you can get a really great audio image with a multi-channel microphone system instead of modeling all those objects separately. And also this is really important because that playback systems of VR and 360-degree videos are really not unlimited in terms of resources for computational power. As I said before, the Spatializer calculates all those things in real time, and its convolutions and other like kind of sophisticated things the playback device has to calculate them in real time. So it's really good if you save some of the resources for other things of your VR or 360-degree experience. And yeah, so multi-channel microphones are really a way to go here. So now I talked about those sound elements that you have here, but as an audio engineer, you have to mix those sound elements somewhere, and so you need some kind of intermediate format for where you mix your sound elements to. This can be also described as an audio bus. And so what kind of intermediate formats do we have here? For the mono audio objects I was talking about, it's easy. It's the so-called diegetic point sources that we have here. So diegetic means something like, it's Greek, and it means something like part of the story. For VR or 360 videos, it means that it will stay at one spot, and when you turn your head, that place where the audio object will stay, but the relation from your ears to that point source will change when you turn your head. So that's diegetic, and the opposite would be non-diegetic, which would be that it would be fixed to your head. So if you rotate and you have, for example, an audio object here, it would rotate with your head. This could be also used for something like a narrator, or maybe also some menu sounds, or in some cases background music. But in VR, background music actually is better if you also do this as a diegetic thing, so something that is embedded in that story you're telling. But that's not our topic here, so let's move on. So for mono audio objects, our intermediate formats are diegetic point sources, and for the multi-channel microphone signals, it's the so-called diegetic virtual speakers then. So this can be imagined like a real normal stereophonic speaker setup. So these stay in the room, and like if you would have your home entertainment system with surround speakers and everything, those are also staying in the room, and if you turn the head, they will stay at that place and will change their relation to your ears while you rotate or while you move around. So where do you place those speakers for multi-channel microphones? For the diegetic point sources, it's easy. It's just where those point sources or where those audio objects should be in the virtual scene. So if somebody moves around, they will change their position with it. But for the diegetic virtual speakers, they will actually stay at the same spot. And where do you place them? In the most cases, something like this is sufficient, or is a good idea to do it like that. So these are just point sources that are arranged around the listener in a cubical shape, so as the corners of a cube, to be more specific. And this is a little bit like the center speakers of a 9.1 listening sound system. We showed the 0 degree line here with the arrow in the listening position in the middle. And then you have like left, height, right height speakers and all on the other four. And this is kind of an intermediate format now where you can mix your audio as a bus. Well, and now I postulated that these diegetic virtual speakers are more or less always the intermediate format for VR. But what about Ambisonics actually? So if you talk about VR audio, almost everyone is speaking about Ambisonics. And so what is the place for Ambisonics here really? Definitely Ambisonics is a really handy tool for VR. It's very flexible, and it has a really big advantage compared to other sound field reproduction methods like wave field synthesis, for example, that it really works well in the sweet spot. And for VR and 360-degree videos, we can really arrange the virtual speakers so that the sweet spot is always where the listener is. So this is really handy here, actually. But the term Ambisonics confuses people nowadays, I would say, because you read it a lot on Facebook or on other platforms, forums, and you really get the feeling a little bit that for using Ambisonics, you really need an Ambisonics microphone. But Ambisonics is much more than just a microphone technique. Well, it definitely can be a microphone array in the one place, but it can also be an Ambisonics bus, for example. It can be a file format, so an input or output file format, which is called an Ambisonics format. You can also talk about ambisonic effects or an encoder or decoder for Ambisonics. So it's really not clear what Ambisonics is when you talk about Ambisonics. I will give you a few examples for those different use cases for Ambisonics, because it can be really handy here, and you can also mix it up with other techniques like stereophonic techniques. But let's first start with like a typical thing, what you would do. You would have a first order Ambisonics microphone, really, and you want to put that recordings into a games engine for making a VR application. So on the left side, we have the microphone array. Now, we can have three different ones here, really. So there's the tetrahedron microphone, which is something that a lot of companies sell. It's that 4 capsules that are really shaped in a symmetric way. And then there's also like a native B format microphone array, which you could use here, which consists of 1 omni microphone and 3 figure of 8 microphones. And then there can be also a triple MS, which is almost the same as a B format microphone, but it has, instead of an 8 and an omni microphone, 2 cardioids pointing to the front and the rear. So, and now with an Ambisonics encoder, you could actually get those signals, which are called 8 format, into Ambisonics, first order Ambisonics B format, intermediate format. So now here, Ambisonics is not any longer a microphone array. Now we are talking about a intermediate format, which is here called B format. And there are different encoders who do that. In the end, you have that bus, and you can use that for different things you want to do. And in the end, you might need to decode it to some other target format. So what is the target format here? In the case where you put a first order Ambisonics recording to a games engine, in this case, this will be also the virtual speakers that we talked about. So a cube could be a solution here, but it could also be something like an octaeder, which also might sound great because it has a great signal separation. It depends a little bit on your recorded stuff and what sounds best. And then if you have that, so you decoded this ambisonic signal to the virtual speakers, you can take all of those virtual speaker signals and put them in Unity on a certain spot, and thus give them separately to the Spatializer. And the Spatializer will take care of it and transfer it to a head-tracked binaural signal. So you could also have that Spatializer with an Ambisonics bus input, like here on the right side. Then it'll be a little bit different because then you can just route the B format directly to the Spatializer plugin. So you might say now, where are the virtual speakers here? They're also there, but they're more hidden. They're now in the Spatializer plugin itself, where the Spatializer decodes the Ambisonics B format into virtual loudspeakers and then also binauralizes those signals for the binaural signal in the end. So it's exactly the same, and actually just put into the Spatializer. So there are ones that have an Ambisonics bus input, there are ones that don't have that. So, but technically they're really the same. So if you have a higher order Ambisonics microphone array, it'll be very comparable. You will put those half omni or cardioid signals that microphone has with an encoder into an intermediate format, which will then be higher order Ambisonics and not first order Ambisonics. It could be third order, it could be fifth order or something. Depends on what you're doing. And then with the decoder, you can also put it into the target format, which will be again the virtual speakers, and then individually take those signals to the Spatializer and get a binaural signal. So in VR you can also have a stereophonic array. I will talk about this later more. So we have here the SCHOEPS RTF 3D, which consists of 8 supercardioid microphones. Those can also go into a Spatializer plugin, but you there don't need any encoding or decoding into Ambisonics. You can directly put them onto that virtual speakers. They have to be designed so that the stereophonic microphone system fits those virtual speakers in terms of like positions and arrangements. But if you do that well, you can then directly take those signals and route it to the Spatializer in different spots in the virtual scene. And then you're done. So we talked about the games engine now. There's also 360 videos with 360 video players as an examples. I have now here YouTube as an output. YouTube has at that moment a first order Ambisonics bus input, and if you take a first order Ambisonics microphone, like the 3 I talked about before, you then again encode them to Ambisonics B format first order, and then you just have to take those 4 signals, which are W, X, Y, and Z. This is the B format, and put them directly into YouTube. So you have directly routed it into YouTube in a way. What YouTube does internally is again the same as before. It decodes 2 virtual speakers, and those will be binauralized individually. So again, also here we have that virtual speakers actually. For higher order Ambisonics to YouTube, this is now a preview because it's not yet there actually. YouTube says that it will support higher order Ambisonics 9+ channels of audio in the future. So that's what they say, and they also note that the support for higher order Ambisonics is currently experimental. So I think there might be some examples already on YouTube where they use third order Ambisonics. And also the Jump Inspector, which is the Google video 360-degree video player, is already equipped of third order Ambisonics as a bus. So we all wait for YouTube to do this and have proper higher order Ambisonics for YouTube, and so this will definitely come in the future. And how do you do this then? You might have a higher order Ambisonics microphone array, encode that to the intermediate format, higher order Ambisonics, and then directly put this into the higher order Ambisonics bus input, which YouTube will then hopefully be equipped with. Internally, as I said, it will be exactly the same. There will be virtual speakers. For the stereophonic array into higher order Ambisonics YouTube, you would there need an intermediate format, which would be, in this case, our virtual speakers. And those then need to be encoded into a higher order Ambisonics intermediate format. So now we have a stereophonic array, virtual speakers, and higher order Ambisonics, and that all works fine together if the order is high enough. And then you can just take that higher order Ambisonics bus and directly route it into YouTube. So I already told you that the virtual speakers are everywhere, kind of almost everywhere there's Ambisonics. I can now tell you that it is definitely everywhere because the Spatializer plugins internally use both most of the times. I don't know it because it's a proprietary system, but like in the theory, it would work like this. You would have on the left side the source, which is a mono signal, like from our virtual speakers, as I stated before, and the metadata, which is the angles in our case. And then you also have the real-time head tracker data. This goes into the Spatializer plugin, and the audio with the metadata will be encoded into a higher order Ambisonics bus. Then with the head tracker data, there will be a Ambisonics rotation, which is very easy in terms of calculation methods on a computer. So this really works well and with very little delays. And then you can decode this higher order Ambisonics bus, which then was turned in real time to the head tracker data, to virtual speakers, and then convolve them with HRTFs again, and thus you will get your binaural signal in the end. So now I talked a lot about those different formats, and this is not so much practice, it's rather post-production really. But if you avoid all those bottlenecks and do that right, you can then focus more on what's really important, and this would be rather how to produce or how to record with those multi-channel microphone arrays for VR. And this will be all done in the third part of my talk, which will be about multi-channel microphone techniques for VR. So see you then.